Okay. Oh. That's fine. All right. Hello. Coming in here for the grade 9s. Very quick lesson for the grade 9s, guys. Just sort of introductory style. The grade 9s and we've been having a very good, you could say, relationship lately. Yeah. Okay. Oh, my soul. Yeah. No, Mr. Who is this person who's joining in here? Pilasande. Kuhle. Basi. Pilasande, I'll do. If you're so eager for me to do functions, especially f of x questions, please, then what you can do is you can come back in 45 minutes time. So let's say, what is it, 7:45, all right, 7:45 p.m. you can come back for functions. I'll do functions for grade 10. Maybe if you have specific questions, you can bring those questions. I'll do a co-live with you, and then you can ask, shoot away. Let's see if you have guest. You don't have guest privileges, ish. Okay, so I'm with my grade 9s, and deliberately so. Hello grade 9s, I hope you are well. It was just yesterday that we had a beautiful session together. I hope all of you have taken the time. Hello Svio. Hello Ria. Labia, hello. I see you there as well. Sweets. So guys, I'm hoping that all of you have, on my YouTube channel, I posted the videos of the 3 live sessions that we've done so far for Term 2. Okay, so if any of you are joining in and you are in grade 9 and you missed the sessions that we had previously, then I would kindly ask, encourage, advise, invite for you guys to go and check out what we have done so far in the channel of YouTube. It's beautiful what we are doing there, guys. Beautiful what we are doing in the sense that all these lessons, everybody has a chance to check them out live, and hopefully we can continue to do this, and we can grow our maths confidence in the process, and also our grade 9 content knowledge, so that we become solid grade 9 students, right? So we're going to look at grade 9. I left yesterday, you guys with 5 questions. Okay, and they were these kinds of questions. Okay, 5 of them. So 25x to the power 10. And all I wanted us to do here was to actually simplify these, you call them roots, so that we can have a level of simplification where they are concerned. Okay, so 25x to the power 10, the square root of 25x to the power 10. Okay, so what do we do when we have a question of this nature? How do we go about simplifying this? Right? Anyone care to maybe come on so that we can have the conversation about what we do? Square root of 25x to the power 10. How do we go about simplifying? Okay. So hopefully we all know that when we have a root, whatever the root is, and the relationship between the bases is multiply, the splitting of the base for multiplication is possible. So this is a rule that applies to roots. Okay, this is something that applies to roots. Gladys will do grade 11 at 9 as usual. Okay, so grade 11 at 9 p.m. as usual. Okay, I'm going to have a grade 9 session, 7:45 I'm going to have a grade 10 session, and then I'll see you guys at our usual time. I'm just hoping that the network won't give me trouble and grief though at that time, because that's what's been happening lately. Okay, so this rule, please guys, let's understand it. The other rule applies to division. When we have a division of bases inside a root, then we can split it up. Okay, very important that we can do that. Now I want to ask this question. What about if we have an addition or a subtraction of bases inside the root? Can we split it up? That's my question to you. I want a yes or a no in the comment section. Can we say this is square root of a plus the square root of b? And can we write this as square root of a minus square root of b? So I'm going to allow people an opportunity to breathe on this. Can we do that? Square root of a plus b is equal to the square root of a plus the square root of b. And when the subtraction, square root of a minus b is equal to the square root of a minus the square root of b. Okay, is that correct? Okay, we saw as with multiplication, we can split square root of a times the square root of b. With division, okay, as long as there's one term inside the relationship is multiply, we can split. As long as the relationship is divide, it's one term, we can split. Now I'm asking, inside the square root, how many terms are there? There are 2. Can we split square root of a plus square root of b? There's only 2 people that have answered so far, guys, and I'm not happy. There are 19 people on the call, at least from what I can see. That is excluding the additional people that are maybe on the sidelines. Okay. No, Lerato, it hasn't been uploaded yet. Is this correct, guys? Square root of a plus b is equal to the square root of a plus the square root of b. Is this correct? I'm asking yes or no. Square root of a minus b, is it equal to the square root of a minus the square root of b? Is this correct? I'm asking you guys. You need to answer me. Basetana is saying no. So far, Sivio has answered. Basetana has answered. Smahlalela has answered. There are 3 people who have answered. Sam. Okay, Sam said yes. Thank you. Itumeleng says yes. Maitsejo says yes. 12 says yes. Okay, so that is 4 no's compared to 4 yeses. Okay, thank you for all of your answers. All right, thank you for all of your answers. This is a critical teaching moment for all of you right now. Okay, all those people who have said yes, guys, when there is an addition, or let's say there are separate terms inside the square root, we do not split. So this is not something that we can do. Okay, so I'm going to write here, this is what we call nonsense. Okay, if there is an addition or a subtraction of terms inside the square root, we do not split for the square root. We don't do that. Okay, it's nonsensical to do so. And maybe a practical example will help you understand why I say that. Maybe if I give you a practical example, you'll understand why. But I need you to all understand that this rule for splitting of the root only applies when there's multiplication. You can see square root of a times the square root of b. For division, square root of a over the square root of b. But for addition and subtraction, it's a no-go zone. It does not apply. Okay. Now, I need you guys to really take this in for a moment. It's very important. It's critical that you grasp these rules that I'm giving to you. All right. Now, I'm going to go back to the questions that we were asked as per the live session yesterday. But I need you guys to take this in. This, like I said, is a defining moment for many of you. Many of you have been taking this for granted. You do this and you basically think that all is well, but it is not. For addition of terms inside the square root, we do not split the square root. But for multiplication and division, we split the square root. So I'm glad that Maitse, for instance, is saying in the comment section, I learned something, and there are beautiful tears of joy that are streaming from her eyes. Those tears of joy, all right, hopefully they are tears of joy because you've learned something, tears of pain because it's like letting go of a once prized, dear loved one. Like that information that you initially had that led you to split this is like that dear prized loved one that you have to let go of because that loved one is toxic in your life. It's not bringing any value. It's not helping you with anything. So you have to let go, unfortunately. So we have to let go of this nonsense. Okay? And we need to embrace the truth. The multiplication, though, leads to a split under a square root. The division leads to a split under a square root. Very important. So I'm coming back to this question now. We need to simplify the square root of 25x to the power 10. 25 is a base. It's a numerical coefficient. X is a base. What is the relationship between 25 and x? 25 and x are combined by what operation? By multiply. So this thing is the same thing as this. So what you can do is you can write the square root of 25 times the square root of x to the power 10. You can split these. Why? Because 25 and x are combined by multiply. So this rule applies to this. Then you ask yourself the question, what is the square root of 25? Obviously, it's 5. Your calculator is there for that. What is the square root of x to the power 10? When we are dealing with the square root of x to the power 10, to remove this root, because this is the square root, it's like taking the exponent 10 and dividing it by 2. Why? Because this is the square root. What if it was the cube root, sir? What would we do if it was the cube root of 10? Then to remove the cube root, we would divide the exponent 10 by 3. What if it was the fourth root, sir? Then we would take the exponent 10 and divide by 4. What if it was the fifth root? Then you would divide by 5. What if it was the sixth root? Then you would divide by 6. So therefore, what we are saying here is to remove the square root for a variable and its exponent. We take the root, we divide by it in order to simplify. So our final answer will be 5x to the power what? What is 10 divided by 2? It is 5. This is your answer. we have simplified, applying the rule that we know and love, which is this rule. Okay. All those who can hear me and understand and have received the message of truth can say amen and hallelujah in the comment section. Flood my comment section, people, with hallelujah and amen, and I will know that you guys are with me and we can move on to the next beautiful problem. Thank you, Milani. Thank you so much. It seems like you're the only one. Maitseho, thank you so much. See that. 21, I see you. Her story animated. I am moving on. And hopefully as I move on, you will move with us and you will be able to grasp where I'm coming from. Okay. Lesejo, you're writing for the sake of writing and you got it right. Well, Lesejo, it just means you have the knowledge inside of you. You were not writing for the sake of writing. Remember, whatever you wrote it is informed by knowledge that you have in your mind and in your heart. That is already there. It just means maths resides within you. And when you don't have to really think about it. It's like a person who drives. Initially, when you first learn how to drive, you have to actually focus and concentrate. Now you putting in the clutch, and then now I am, changing the gear one. I'm doing this. You do that for a very long time until you become so good at it. It becomes second nature. And when it becomes second nature, you don't really think about it too much. Okay. All right, so here, this one, it's the cube root of 8y cubed. 8 and y have which kind of relationship? 8 and y are multiplied. 8 and y are multiplied. So what can we do? We can split the cube root. I hope you can understand. Because there's a relationship between 8 and y of multiplication. So we can use this rule. Then, what is the cube root of 8? It is 2. And then the cube root of y to the power 3, okay? Y to the power 3 divided by 3. The exponent 3 that is there gets divided by the root, the cube root, when we remove the root. So it's 3 over 3. What's the final answer? 2y to the power 1. But we know that 1 is always there, though invisible. It is ever present, ever there to stay. Maths has made me believe in God so much, because in maths there are things that are there but we don't see them. Okay, so hopefully those who have joined in can now understand what I did in this first problem. 25x to the power 10, I could see that 25 and x have a relationship. What combines them is multiply. So that means I can split the square root of 25 and the square root of x to the power 10, simplify them independently. Square root of 25 is 5. X to the power 10, the square root is x to the power 10 divided by 2, which leads me to 5x to the power 5. Let's go to number 3. The third question that I had actually given to you to do. 4x to the power 3 plus 4x to the power 3 into 2x to the power 5 to the power 3. Okay. No, see for life. We are simplifying. Okay, we are simplifying here. We are just simplifying a given expression. Okay, wanting the value of variables. No, I don't know what you're thinking about. Why are you asking me, are we wanting the value of the variables? Maybe you can answer that question to me. Okay, we're given an expression. We are asked to simplify it. Okay. I think it's important. Some people here are just negative when they come into this live session here. So the cube root, we have 4x to the power 3 plus 4x to the power 3 into 2x to the power 5 to the power 3. So what we can see in this particular question is that inside this cube root, we have to first simplify the inside. How many terms do we have in this particular expression inside the cube root? There is one term inside the cube root. But you can see there are individual brackets for the cube root. So we can take each individual bracket and we can sort things out, considering our important guest of honor, BEDMAS. We look at brackets followed by exponents because that's very important in our order of operating. So brackets we can see. So let's start there because BEDMAS requires that. So our brackets, we can see this bracket. Oh, we have like terms. 4x cubed plus 4x cubed. We can add like terms. So by taking care of that bracket, we get what? We get, what's 4x cubed plus 4x cubed? My beautiful maths gamers, gamers of maths, the only maths gamers that rule the world. 4x cubed plus 4x cubed gives me, we keep the variable and its exponent, and then we add the coefficient. So it gives me 8x cubed. Then we go to this bracket. We sort out what's here. 25x to the power 5, this bracket, followed by its exponent. So we take care of the exponent, apply the exponent in the bracket that is it refers to. So we have 2x to the power 5 raised to the power 3. Remember, when we distribute the exponent, we distribute it by multiplication to each respective exponent. There's 2 to the power 1, there's x to the power 5. So what does that give us? 2 to the power 3. Okay, 2 to the power 3. And x to the power 5 times 3, 2 to the x to the power 15. Okay, we are moving along just briefly and slowly. 8x cubed into 8. Remember, 2 to the power 3. Please, guys, let's not make the mistake of saying 2 to the power 3 is 6. McFinney. 2 to the power 3 is 2 times 2 times 2. When at loss, please go ahead and punch this into your calculator so that you do get the answer 8. McFinney, it's so painful when we make the error of writing 2 to the power 3 as 6. It is not 6. Okay? Yeah. That time must come and go. We cannot be making silly mistakes like that. Now we can multiply 8x cubed times 8x to the power 15. 8 times 8. So now exponents, we were done. We were done with exponents for that bracket. There's no division. The next step, multiplication. So we multiply these two using S, N, L. Let's not forget that, guys. Sign, number, letter. Positive times a positive is positive. 8 times 8 is 64. X to the power 3. So the sign is done. The number is done. Now we need to take off the letter. X to the power 3 times x to the power 15. Keep the base. We add the exponent. What's 3 plus 15? It is 18. Now, guys, we are at a beautiful place where we can officially take care of the split. It's time to split. This is the only time, guys, a algebraic divorce can happen. An algebraic divorce. All right. Cube root of 64. Cube root of 64, guys, is equal to 4. Thank you very much. X to the power 18. We remove the cube root by taking the 18 and dividing by 3, which gives us what? 4x to the power, what's 18 divided by 3? Thank you, my sejo. 6, 12, 6, here for life, 6. 4x to the power 6. Okay. Rajodo is asking, why are you separating? The law allows me to separate. The law allows me to separate. a times b, when the relationship between bases is multiply and there's a root, that allows us to separate the square root of a and separate the square root of b. Multiply square root there times the square root there. The relationship between 64 and x, what combines the 64 and the x, is multiply. So I can cube root the 64 and cube root the x to the power 18 because the relationship is multiply. Therefore, answer for x to the power 6 is our final beautiful answer. Can I please show the bad mess again? There it is. B stands for brackets. E stands for exponents. D stands for division. M stands for multiply. A stands for addition. S stands for subtraction. That is bad mess. Whenever we are dealing with an expression, we always consider bad mess. Why? Because different operations lead to us applying bad mess. In order for the maths to maths, we need to ensure that bad mess is applied. Hence, when I looked at this expression initially, what does SNL mean? SNL means whenever you are multiplying or dividing, you consider the sign, which stands for S, the number, which stands for N, the letter or the variable, which stands for L. So, for instance, when I got to this spot, do you remember when I got to this particular step, what did I do? After brackets and after exponents was sorted BE. I then checked, is there division? No. Is there multiplication? Yes. This is multiplied with that because of the brackets. Now, when I multiply, I consider multiplying first the sign of the two numbers. Positive times a positive, positive. Then I move on to the number coefficient. 8 times 8 is 64. Then I move on to the letter or the variable. X to the power 3 times x to the power 15. Keep the base, add the exponent x to the power 18. That's what SNL stands for. When dealing with multiplication or division, we always divide and multiply using multiply the sign or divide the sign. Multiply the number or divide the number. Multiply the letter or divide the letter. That is basically SNL. Get 64x to the power 18. Divorce happens according to the rule, because for multiplication, splitting must happen because the relation between 64 and x is multiply. So we split the cube root for both, and then we apply the cube root. Cube root of 64 is 4. Cube root of x to the power 18. I said we remove the root, retain the exponent 18, divide by whatever the root is concerned. So if it's square root, we would have divided by 2. Since it's the cube root, we divide by 3. If it was the fourth root, we divide by 4. If it was the fifth root, we divide by 5. If it was the sixth root, we divide by 6. If it was the seventh root, we divide by 7. If it was the eighth root, we divide by 8. I'm sure you get the point. And then you get this beautiful simplified answer. Sweet? Sweet. Thank you so much, guys. That was amazing. Okay, even if I must say so myself, that was amazing, amazing, amazing. Next beautiful question. 9 square root of 9x to the power 16 plus 16x to the power 16. Square root of 9x to the power 16 plus 16x to the power 16. look at the square root, look at the terms inside. How many terms do we have inside the square root? That's the first question we need to ask. How many terms inside the square root? Yes, very good. There's 2 terms. Those terms are separated by a plus sign. What sort of terms are these? Because whenever 2 terms are separated by a plus sign, we need to then ask the next question. Are these like terms or unlike terms? This is 9x to the power 16. This is 16x to the power 16. Ooh, people are saying they are like terms. If then these are like terms, what can I do with them? Oh, Milani writes the answer there, hey? Yes, yeah, we can add them. Yes, Maitsejo. Yes, Fani. All right, we can add them. So let's go ahead and do that. Anyone who was feeling like, let's split this thing? Let's split it? Was there anyone who was thinking that? Let's split these 2. Can we split the square root? Can we split the square root? If not, why? Oh, Maitsejo, that's true. I'm sure you would have. If you would have entered my live late, you would probably have said we can. Okay. We can't split the square root. I said earlier on, if there's an addition or a subtraction of terms inside the square root, splitting it is nonsense. Absolute nonsense. Rubbish. I don't know what else to call it, but we don't do it, guys. We don't split when there's addition and subtraction. So I like the root that we have taken. We saw that these are like terms. So with like terms, what do we do? What do? We keep the variable and its exponent, and then we add the coefficients. What's 9 plus 16? It's 25. Now, I'm sure you can see that, oh, what relationship now do we have between the 25 and the x to the power 16? They are combined by what? By multiply, because it's one term. So can we now split, guys? Because splitting is something that it seems like it's the thing when it comes to square roots. Yebo indeed. Yebo indeed. So square root of 25 times the square root of x to the power 16. Then what does that lead us to? What's the square root of 25? Key 5. The square root of x to the power 16. I hope you guys can remember what we said we do whenever we want to remove the square root. Milan is already ahead of the game there. We obviously would remove the square root by dividing by 2, which leads us to 5x to the power 8. Nicely done. Nicely done. Okay, thank you. Right, then the last correction that was there for yesterday was this one. 81x to the power 6 plus the cube root of 27x to the power 9. 81x to the power 6 plus the cube root of 27x to the power 9. Yes, I do grade 10, and I'll be doing grade 10 at 7:45 exactly. I'm ending this live at 7:35. Then I will start the grade 10 live session at 7:45. 81x to the power 6, the square root of 81x to the power 6 plus the cube root of 27x to the power 9. I don't want to keep people long today. I want to have just a nice brief session. Goodbye, leave you. You know what I mean? No chilling and staying around for long today. I'm just touch and go. Tuli, technical maths per se specifically? No, not directly. I do grade 11 maths, as in like the actual pure maths. Yeah, I know. I think there's aspects of that technical maths that me is not familiar with, because I've not explored that topic fully, but I do know that things override with the two topics. Okay, grade 12 maths, yes I do, but like I said, it's been a while, it's been a minute. I think today I might just do, but I'll do a grave, like I'll do a 10:30 session with the grade 12s. That's if they are up for it. I know it's going to be late. It's a school night tomorrow. Well, it's a school night today. So, I mean, tomorrow is day one back at school. But yeah, guys, you have my YouTube channel. When I'm done with the session, I try as much as possible to download the session and then I post it onto my YouTube so that people can go and review and hear my beautiful, amazing voice on that channel as much as they possibly can. 81x to the power 6, the square root of 81x to the power 6. Okay? Yeah, it is. I know it is. Plus the cube root of 27x to the power 9. All right? So this is already the square root. It's separate and apart from the cube root. So obviously then this means deal with him alone and deal with him alone. And if by some chance addition is possible, because after dealing with them they are like terms, then we can take care of them. But if they are unlike terms, we leave them and they remain separated. So I'm sure you guys know what we ought to do here. The square root of 81x to the power 6, that means square root of 81, the square root of x to the power 6. We separate. On the other side, it's the cube root that we separate. Cube root of 27, the cube root of x to the power 9. Then we apply our maths there. What's the square root of 81? It is 9. Square root of x to the power 6, x to the power 6 divided by 2. Okay, which I'm sure we will work out just shortly. Then we move on to the cube root. Cube root of 27, that is 3. Then cube root of x to the power 9. 9 over 3. Finally, the grand finale, 9x to the power 3 plus 3x to the power, what's 9 divided by 3? It's 3. Oh, look at this, guys. We have been led to having two terms, and these two terms are actually what kind of terms? What kind of terms? 9x to the power 3 plus 3x to the power 3. These are like terms. They are alike. So let us like them up. Like them up. As we like them up, we get a beautiful answer of what? It's said when learners leave the answer like this and they think they are done, but they don't see like terms, So when they are like terms, what's the answer? This is grade 10. This is grade 9. I'm elevating these kids. 12x to the power 3. Yeah, finally. The finale answer. Right? Grade 9s. I hope you have followed along with the logic and the order and the build-up of what we have done today. All right, this is all that I had for you today, guys. All right, so that officially concludes our grade 8 revision of algebraic expressions. It officially concludes our revision of grade 8 work. How do you feel that we have finally concluded? Okay, I hope you feel great that we have finally concluded the grade 8 revision. Okay, yeah, because guys, we have literally covered so many bases with the grade 8 revision. It's so important to cover the bases that have allowed us to cover. All right, yeah, and by so doing, we are in a very good position now to actually head out and start doing the grade 9 work that is basically lined up for you guys. Okay, so I think without any further ado, like I said, I'm gonna have a grade 10 session at 7:45. So I think I'm gonna let you guys go. Just wanted to sort of make sure that we do this very quickly. Yeah, and let me just say to you, grade 9s, everything of the best for when you guys go back to school. Are we going to start with factorization? No, funny, we're not going to start with factorization because we are still after this going to deal with products. Maybe for the next 10 minutes, let me do this. Let's start out because in grade, let's look at something here. In grade 9, we look at this: the product of a binomial with another binomial. That's what we start out with in grade 9, the product. Okay, obviously you guys know how to multiply a monomial, meaning one term, with two terms. You also know how to multiply a monomial, meaning one term, by three terms. Okay, yeah. Now we need to do the products. Okay, and nearly, if you honestly struggle with factorization, then that means the next few sessions in the future, in this week, will be important for you to actually join in those sessions. All right, because that's where we will actually deal with factorization, starting off with highest common factor factorization. Then we'll do difference of two squares. Then we'll do grouping factorization. Then we'll do trinomial factorization. All right, so all of these factorizations, they are so easy. No, there's no schedule for the sessions. The reason being, I am having serious problems with my network at the moment. And what usually happens is that Vodacom, I don't know what's been happening with my Vodacom connection, and I'm actually still working on getting a stable Wi-Fi connection in my home, so that I don't, hopefully it will dispel that problem. Hopefully by Wednesday, I will have that problem sorted out. But for now, hey guys, I set a schedule, then I can't honor the schedule, I can't honor that time, and then people get angry and they become dissatisfied and unhappy. So I can't live that way, unfortunately. Thank you so much there for the recommendation, my dearest Lesego. I really appreciate that. We'll look at those too. There's something that's on the way at the moment that I'll be checking out on Wednesday. That's hopefully going to be more stable for me with the connection. So, but thank you for the listed options. All right, I'll do one example of this so that you guys can kind of see what we mean by this. So how do we multiply the binomials? Thank you, Shawnee. Really appreciate the roses there. How do we multiply two binomials? How do we go about it? All right. So there's this concept that they refer to as eFoil. Okay. The F for foil simply stands for first, and by that they mean the first terms of each bracket. So if you go inside each bracket, the first terms for each bracket, you have here an X, okay, and then here we have an X, okay. So there's an X here and there's an X there. Those are our first terms, okay. And obviously the brackets, they mean what? They mean we must multiply. So what we do is we multiply in this order. We multiply the first terms. And when we do so, please, we know that when we multiply, we always consider S and L. So our first terms must be multiplied. Then after that, our outer terms must be multiplied. By outer terms, we mean the second term. We mean this is the first terms that we multiply. So it's like we are taking this X, we are distributing it to the X in here, and then we are taking the very same X, we are distributing it to the last term. These would be referred to as our outer terms. All right, they are our outer on the left, outer on the right. So we multiply our outer terms. Then we multiply the inner terms. So if you think about it, we multiply X with X, we distribute the X here, we distribute the X there, we are done. Then we move on to the second term. We distribute the inner terms, 1 and X, and then we take the same term, we distribute it to the second term. Hence, we call these our last terms. So FOIL, FOIL, multiply the first term, multiply the outer terms, multiply the inner terms, multiply the last term, multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last term, multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last term, multiply the first term, multiply the outer term, multiply the inner term, multiply the last term. So when we do that, then we actually are able to FOIL. Of course, this is in the condition that our two terms inside that specific bracket are unlike. So this is an unlike term binomial and as well as an unlike term binomial. We apply FOIL for two unlike term binomials. So FOIL specifically applies to that. Okay, so I hope you understand, because of course I'm sure you saw there was a question that I did last night. I'm just trying to find that question. There was a question I did last night, where there was two brackets. This is the question, this one. 2p minus 4p into 2p squared minus 1. Okay, and these are two binomial brackets, but you notice something about this first bracket, that they are like terms. And if you remember, what we did last night is we didn't use FOIL here, but we simply took the like terms and we subtracted them. We got negative 2p. This is actually a monomial term, and then inside this bracket there's a binomial. So then we use the distributive law for that single term multiplied by two terms. So we did not apply FOIL here because there was like terms in this bracket, and in this bracket they were unlike. This FOIL is applied when we have two brackets that have unlike terms. That's very important. Two brackets that have unlike terms, we apply FOIL. So let us rewrite this question and then see what the multiplication of it leads us to. So what did I say? We multiply the first term. So what is x times x? It is positive times a positive is positive. So the sign is positive. 1 times 1 is 1. Then x times x for the letter is x to the power 2. So we are done with the first terms, multiplying them. Then we take the same x, we distribute it to the 1. So now we apply S and L when we do that. Positive times a positive gives us a positive. X has a coefficient 1. 1 times 1 gives you 1. And then the x times the 1 gives you a x. So whether you write 1x or x doesn't really matter. At the end of the day, 1x and x are the same thing. Then we take the second term and distribute it to the first term in the bracket, the inner terms. Positive times a positive is positive. 1 times x gives you another 1x. And then last but not least, 1 times 1. Positive 1 times positive 1. A positive times a positive is positive. And then 1 times 1 gives you 1. Okay. Now that we have finished the foiling, then we look at our terms. How many do we have? 4. Are there any like terms? Because those like terms, if they are present, we need to actually take care of them. So that leads us to a final answer of x squared. What is 1x plus 1x? Because yes, guys, they are definitely like terms. 1x plus 1x, we keep the variable. When we are adding like terms, we add the coefficient. That leads us to an answer of 2x. and then our last term is 1. Okay, guys, hopefully that was simple enough. Okay, so a binomial by another binomial should then lead us to a certain number of terms. When we have like terms, we make sure that we add and subtract those like terms. So after we FOIL, we check like terms, collect, and we sort them out so that we get a simplified, the most simplified answer that we can get. Okay, now I don't understand Sima's question. Why can't we say it's x squared? What do you mean? Why can't we say it's x squared? What are you talking about? Are you asking about why can't we say 1x plus 1x is 2x squared? Is that your question? Okay, because remember, we are adding terms here and they are like terms. When we are adding like terms, we keep the variable as it is. We add the coefficients, right? Yeah, we are not multiplying 1x and 1x, because when we are multiplying, there's a different rule that applies to multiplication of variable bases. Okay. Right. So I'm going to leave you some game challenges to do, and then they won't be long, just 3 game challenges, and then I'll see you tomorrow in the next live. Okay, you can do these for me, simplify them, all right? And I will see you guys tomorrow. Please screenshot because I need to bounce now and leave you guys. But this has to do with the multiplication of binomials that have unlike terms. FOIL is applied when we have a binomial, but you can see inside each bracket, it's unlike terms that are there. Then we apply FOIL for those situations. Okay, right. I hope we are good now, and this Maths is a Game host can now love and leave you guys in peace. All right. Thank you so much for joining in. Such short notice for some of you. I know some of you were, yes, we only apply FOIL in the expression when, like I said, we have 2 unlike terms for each bracket. Then that is basically what we apply when we have 2 unlike terms for 2 binomial brackets. When they are multiplied together, we basically apply FOIL. Okay. Thank you so much, guys. It was great. Very, like I said, straight to the point, short, not too long. Yeah, I'll be uploading this on my YouTube channel. You can also check out the videos that we have done, the live sessions that we have done previously. There are videos that are posted up for grade 9. I've specifically made a playlist on my YouTube channel for grade 9 term 2. So everything that I do here, I'll be posting it onto my YouTube channel, so that if people missed maybe a part, they missed the first part of the session, they missed the middle part of the session, you can always go and review and rewatch at your own time, own pace, under your own sort of like supervision, and you're more than welcome to ask me a question whenever you want. Guys, I don't have the specified time when I'll do the live again. Guys will just have to play it by ear. Like I said, I have an unreliable network connection at the moment. It's giving me, you know, those vibes that I can't really specify, and I can't come up with a stable schedule. But as soon as I fix my situation, hopefully after Wednesday, then I will know, and I will let you know of a sort of like consistent, ever-abiding schedule. But thank you so much. Have a good one, and I'll see you on the flip side. Remember, you guys have textbooks, you have past papers. You can always go and check other questions around this same topic, and you can practice, because remember, practice makes permanent. That's what practice does. It makes you become like, let's say Ho did a question here, and she was like, I didn't even know that I was supposed to do those steps. I was just doing it. You see, sometimes when you've done maths and you do maths a lot, that's what happens. The maths just sticks in you, and you do things without even really thinking, and they are right. you know, without taking much thought. So let's get to that place, and I'm sure we'll be good. Have a good one. Thank you. Goodbye, viewer. Bye, bye, Mini. Bye. Let's say, oh, bye, everyone. Bye, everyone that's here. And have a good day. And thank you so much as well for the gifts. I really appreciate them. I acknowledge those flowers, those roses that were sent. I really appreciate them from that particular learner, Oshoni. Thank you so much. I'll see you guys. Cheerio, cheerio.